Hello and welcome to the V1 Avionics project site. This project introduces an SIM429 digital avionics interface to the simulator builder community. V1 Avionics is a startup in the United States in partnership with a team of avionics engineers in Spain. Our company is rooted in real-world avionics development and building and designing of safety-critical systems. Building simulators is our passion, just like it is your passion. And V1 Avionics is based on the desire of bringing the abilities of real-world digital avionics to the simulator building community. We want to do so on a budget that you can afford. Our interface allows the connection between a consumer-grade simulator, such as X-Plane or FSX, to real-world avionics hardware. It uses the SIM429 protocol, which is a protocol used on many transport aircraft even today. The internet has made it easy for simulator builders like yourself to get access to real avionics. Many of these avionics devices are based on the SIM429 protocol, and this is where our interface comes in. It allows you to connect real-world avionics to the flight simulator. Many real-world avionics devices, such as this radio head here, for example, or this horizontal situation indicator here, for example, are accessible and available on the internet out of surplus. Serious simulator builders are able to purchase these devices, which are still in many cases functional, and connect them to their flight simulators with our interface. So all these pins you see back here have an output that produces a signal, an SIM429 compatible signal, that can be interfaced with the flight simulator. The same holds true for other well sought after devices such as altimeters, like this guy here, or radio heads, like its ATC radio right here, that is SIM429 compatible, or this radio head right here. So let's go to the workbench and let me show you how this SIM429 interface works and how it can be interfaced with your flight simulation software. So here's our interface. There is a light for receive, transmit, status, and power. Other than that, there is not much other stuff on the interface except for the input and output to the interface. We transmit data between the flight simulator and the interface using Ethernet, bidirectional obviously. There is a power connector, and then there is an SIM429 connector that allows for receive and transmit and grounding. So let's say we want to interface this ATC radio here. The problem with real flight hardware is that many simulator builders have trouble interfacing this hardware with consumer-grade flight simulators such as X-Plane and Microsoft's Flight Simulator. Our interface solves this problem. Let's connect the ATC radio head to a SIM429 interface. We do that with two cables that implement the electrical standard of SIM429, A and the B side. Once the airing data is received by the interface, it is immediately sent on to the simulator. In our case, we're just dumping the data out to the screen. But you see that the airing data is being received from the ATC radio head through our interface to the computer. If we look at the data transfer right here, let's just dial in a code here. You'll see that the interface more or less immediately updates the data into the computer. Let's look at the interface again in more detail. There's a power connector that's somewhat optional if you power it over Ethernet. The airing interface is capable of 12 kilobit and 100 kilobit per second. And the Ethernet interface is capable of 10 and 100T of a speed. So the interface has a pretty broad range of capabilities. To show you the integration of the radio stack with VATSIM, a popular simulator or air traffic control solution on the internet. So first what we do here is we go to Atlanta, and I'm going to put us onto the north ramp. And what's implemented here is the radio stack talking to the flight simulator through our interface using the SIM429 protocol. So next I'm going to log into VATSIM using Xquark box, and I'm just going to go ahead and log in here. And you'll see the message that I'm now connected to the individual audio feeds in VATSIM. The other thing I can do is I can see who is actually online, and that shows me the individual frequencies that are available. So you see here is the frequencies around Atlanta and the individual people working the channel. So first thing, we're going to dial into 125.55, and we're going to listen to the ATIS information. So let's go ahead and dial in 125.55, and what that will do is it will set the frequency on the computer via the SIM429 interface. And we can hear now the VATSIM ATIS information. During the development of our interface, we used a number of development methodologies. We used agile development for the software portions in the interface, firmware as well as the device driver software, and we used standard industry CAD software such as EagleSoft to build our boards with. High volume production of our interface will be done in both Europe as well as Asia. We anticipate a production volume of at least 100 interfaces, if needed, per month. Your contribution here on Kickstarter will enable us to finalize the high volume production of our interface and push it into the market.